In this question, we need to understand how a computer can represent a black and white image as a series of zeros and ones, so how it can store an image as binary data. 3 marks up for grabs, so we'll try and understand what you need. I'll try and explain what we need to write down for each mark, but then also give you a little bit more detail so you can understand what's happening behind the scenes. So if we start with a black and white image, we've got one here of a smiley face. The first thing we need to understand, the first mark that we get, is for saying that you need to split your image into individual pixels. So I've split it here into 16 pixels across by 16 up and down, and you can see that as you split it into pixels, you lose some of the quality. So the more pixels you split it into, the better quality, but the more space it's going to take up on disk. So for your first mark, all you need to write down is that you need to split your image into individual pixels. So the colour of each pixel can be different. So the second mark, you'd write down that each pixel can be represented as 1 bit, a 0 or a 1. And then for the third mark, you'd say that black can be 1 and white can be 0. So quick recap. First mark, your image needs to be split up into pixels. Second mark, each pixel represented by 1 bit. And third mark for saying that black can be 1 and white can be 0. So stop now if you just want to answer the question, but keep on if you want to understand how that works. We've got an image here, and you can see how each pixel can be a 1 or a 0, and that determines the colour. And you can see the binary data here. We've got a byte represented by 8 pixels. So each bit is just 1 pixel, but as you get 8 bits together, that represents 1 byte in binary. So I've converted it into hex here, and if you save this image, we should be able to see that image here, and you'd think that it would just be those zeros and ones stored inside that file, but there's some additional stuff stored in there too, because the computer also needs to understand a few other things. So let's have a look and see what happens when we click this button that converts the zeros and ones into the image file. So inside here, as well as storing, so this is a loop that goes through every pixel in our grid, and it writes the bitmap data to the file. But before we do that, I'm not going to go through this detail, but you can see how it saves some other stuff first. So first of all, it saves the letter B and M at the very beginning of the file, for B for bitmap, and that's what this type of image is. It's a map of bits. It's like a treasure map of trying to find an individual bit. So this is called the header of the file, some additional metadata that tells the computer how to interpret the rest of the data. So it needs to store things like how wide the image is, how high the image is, and it needs to know what the colours are inside the image, so what the white looks like and what the black looks like. If you want any more detail of this, you can have a look at this Wikipedia page, which explains the file format of a bitmap image. And the way to represent a colour image, so any image that you see on a computer, is pretty much the same, other than instead of just being 1 bit per pixel, so a 0 or a 1 representing white or black, you'd store the amount of red, the amount of green, the amount of blue light for every pixel separately. So that would mean instead of 1 bit per pixel, you might have 24 bits per pixel. So 1 byte, 8 bits for red, 1 byte for green, 1 byte for blue, and then you move on to the next pixel and the next pixel. So you can quickly see if you've got, say, an 8 megapixel camera, each pixel storing 24 bits, it's going to take up a huge amount of space to store that image. So what tends to happen if you're storing images, you compress that data, so you lose a little bit of quality in order to take up less space on disk. But remember, just for this question, if we go back to the original question, the 3 things you need to write down are: 1, you need to split your image up into individual pixels. 2, each pixel can be represented as 1 bit, and then that bit for the third mark could be a 1 for black or a 0 for white, or vice versa.